We are looking at R.D. Sharma Solutions, Class 11, Chapter 17, Combinations, Exercises 17.1. First is evaluate the following. 14C3. Please remember NCR is equal to factorial n by factorial r, factorial n minus r. And this n is here is 14, r is 3. So factorial 14 by factorial 3, factorial 14 minus 3. So always convert the higher into lower, 14, 13, 12, factorial 11. Then you have factorial 3, write it as 6. And then you have factorial 6. Just cancel it. And 12 and 14, 13 into 2 is 364. So you have to do it for all other questions like. So 12C10 is factorial 12 by factorial 10, factorial 12 minus 10, that is 66. 33C35. No, I need to tell you about this. See, this is a type of NCN, and that means 1. So factorial 35 by factorial 35, factorial 35 minus 35, and factorial 0, this is cancelled. So NCN will always be 1. N plus 1 Cn, n plus 1 Cn, factorial n plus 1 by factorial n plus 1 minus n. So this is going to be factorial n plus 1 by n plus 1, let us open this, n plus 1 factorial n is the denominator, cancel it, this is going to be n plus 1. So one thing you understand here, n plus 1 Cn is n plus 1 always. Now sigma means addition, that means from 1 to 5, you have to put 1, then 2 till 5 and then add them. Sigma means summation, sum, 5C5. So now just add them and you are going to get 31. Now we have the questions where we have to find the variable, find the value of n. So the question is NC12 is equal to NC5. When this is there, see NCX is equal to NCY or NCP equal to NCQ, that means x plus y will be equal to n. This is the relation. This is the theorem. So what is P plus Q? 12 plus P is 12 and Q is 5. So n will be equal to 12 plus 5, that is 17. N will be equal to 12 plus 5. So it is going to be 17. If NC4 is equal to NC6, we have to find 12Cn. NC4 is equal to NC6, we have to find 12Cn. So that means 4 plus 6 is equal to n, P plus Q is equal to, and then we have to find 23Cn. So n is already found, 10. Now we have to find 12C10 we have to find. 12C10. So 12C10 will be factorial 10 by factorial 10, factorial 2. And this is going to be 66. Now we have NC10, 23, Cn we have to find out. NC10 is equal to NC12. So just add them. 10 and 12 is added and it is going to be n. So it will be 23 Cn, n is 22, 23 C22. We already seen that n plus 1 Cn is what? N plus 1. You can directly write this. This is also a theorem. N plus 1 Cn is n plus 1. This is going to be 23. (24CX) is equal to 24C 2x plus 3. So we have to find out the value of x. So let us write what is being given. It is 18. I'm doing the denominator, or let us say the fifth one. 24CX is equal to 24C 2x plus 3. 24CX. Now that means x plus 2x plus 3 is equal to 24. X plus 2x 3 equal to 24, and that is going to be 3x plus 3x equal to 24 minus 3, that is 21. X is equal to 7. Now same thing we are going to do for the same thing. They are almost same. 18CX is equal to 18x plus 2. So that means x plus 2 is going to be 18. X plus 2 is going to be 18. So 2x plus 2 is 18. So 2 is here. 2x is equal to 16. X will be equal to 16 by 2, that is 8. Now we have 15C3R is equal to 15CR plus 3. Now 3R plus R plus 3 is going to be equal to 15. So 4R plus 4R equal to 12. R will be equal to 3. R will be equal to 3. Now we have 8CR minus 8CR minus 7C3 equal to 7C2. Now we are taking 7C3 on the right hand side. So 8CR equal to 7C2 plus 7C3. Now I am writing 8CR as factorial 8 by factorial R factorial 8 minus R. And this factorial 7 factorial 2 by factorial 7 minus 2. That is factorial 5. Then we have this one as factorial 7 factorial 3 factorial 7 minus 3, that is going to be 4. Now writing 8 this has 8 factorial 7 and factorial R remains here, factorial 8 minus R remain here. This is factorial 7 by factorial 2. Now I am writing this 5 factorial as 5 into factorial 4. Then we have this factorial 7 again, factorial 7, and this factorial 4. I am writing this factorial 3 as 3 factorial 2. Let it be factorial 3 also, it doesn't matter because, yeah. Is it cancelling somewhere? Write it as 3 into 2 and factorial 4. Now just cancel these 3 because they are the common. Now, so you have to multiply them now. 1 by factorial 4 and 2 take common from here. And you will get 1 by 5 plus 1 by 3. You have taken 1 by 2 factorial 4 common. 2, 4, 2, 4 you have taken. So 5 and 3 are there in the denominator. So what will be 1 by 5 plus 1 by 3? It is going to be 3 plus 5 by 5, 3 is a 15. So 8 by 15 it will be. 8 by 15. So 1 by 2 factorial 4 and then 8 by 15. Now we have 8 by factorial R factorial 8 minus R, and just cancel this 8, 8. So you will get factorial R factorial 8 minus R equal to 2 into factorial 4. Factorial 4 is 4, 3, 2, 1 and 15 is 5, 3 is a 15 we can write. We can write 5, 3 is a 15. Now if you see here, 3 and 2 are repeated. 3 and 2 are repeated. So let us take them separately. So I am writing 2 and 3 separately and then others on the right hand side. That is 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. Okay, 5, 4, 3, 2, 1. Because 3 and 2 are repeated, we have taken it earlier. So this is 6. This is going to be 6. And this is factorial 5. Now let us compare this. Factorial R, factorial 8 minus R. So R is what? 6. Factorial R. And 3 into 2 into 1 you can write. So you can make it as factorial 6. Factorial 3 you can write. 3 into 2 into 1 can be written as factorial 3. So factorial R is factorial 3. R is going to be 3. So 8 minus R will be what? If you take 8 minus R, see R is factorial, R is 3, so the other also matches. Now there is one more method or one more solution. Now you can take these, you can change the positions. So it can be factorial 5 into factorial 3 and now you compare it with factorial R. Now when you compare here, factorial R, so this is going to be now, R will be factorial 5. When you compare this now, so factorial R will be factorial 5. So R will be 5. So R can be 3 also. R can be 5 also. Now we have 15CR is 2 means division, proportion. So 15CR is to 15CR minus 1 is equal to 11 is to 5. What is 15CR? Factorial 15, factorial R, factorial 15 minus R. And you have to divide these two. Factorial 15, factorial R minus 1, factorial 15 minus R plus 1. 15 minus R minus 1, that is 15 minus R plus 1. So that is going to be 11 by 5. This is, let us take it above. Factorial 15 into this, this will go up. Factorial r minus 1, and this will be 16 minus r. 16 minus r. And then you have this one, factorial r, factorial 15 minus r, and then factorial 15. So 15 factorial you can cancel. Now this r minus 1 and r, you can expand it. So r minus 1, and this will be factorial r minus 1. This 16 minus 1 will be 16 minus r, factorial 15 minus r. And then you have 15 minus r already, 11 by 5. Now these two gets cancelled, these two gets cancelled. So you have 16 minus r by r equal to 11 by 5. Now just multiply these two, you get 80 minus 5r equal to 11r, 80 will be equal to 60r, and r will be equal to 80 by 6, that is going to be r equal to 5. Next is n plus 2 C8 is 2, colon or proportion, n minus 2 P4 equal to 57 by 16. So we'll try to solve it using the comparison method. First, let us reach to that point. And factorial n plus 2 by factorial 8 by factorial n plus 2 minus 8. That is going to be n minus 6. And then we have n minus 2 by factorial 4 by factorial n minus 2 minus 4. Minus 4, that is n minus 6. N minus 6. 57 by 16. Now take these above. Factorial n plus 2 by factorial 8 factorial n minus 6. N plus 2 minus 8 is factorial n minus 6. Now this goes up. So this will be a factorial 4 and factorial n minus 6 in the numerator. Factorial. When we take it above, so that is going to be factorial. So it will be factorial 4 factorial minus 6 above. Now n plus 2, can we write in some way so that it gets cancelled with n minus 2, and we have to change them so that things get cancelled. If you see n minus 6 are there, so you can cancel them. This factorial n plus 2 can be written as n plus 2, n plus 1, then you can come at n, then n minus 1, now factorial n minus 2. Now since we have this factorial 8 also, you can write it as 8 into 7 into 6, 5, 6, 6 into 5 into factorial 4. Already factorial 4 we have in the numerator. And then you have factorial 4 cancel. Factorial n minus 2 is there, and this cancels, right? So you have n plus 2, n plus 1, n minus 1 is equal to, now we have on the right hand side 57 by 16. So take on the right hand side 8 into 7 into 6 into 5, and then 57 by 16. So you have to do some calculations here, and then you have to find out what calculation will be equal to. So when you solve this multiplication, whatever I am doing it, that is equal to 21 into 20 into 19 into 18. So that is very important. This step is very important. Otherwise, you got to solve n plus 2, n plus 1, n into n minus 1. That will be a very tedious task. So you have to be very aware that whatever multiplication is, you can write it into 21 into 20 into 19 into 18. So when you compare it, because now you are going to compare it with the variables, or you can say the expression on the left hand side. So what do you get? Whatever cancellation you want to do, you can do. But the thing is, you have to write in this way so that it equates with n plus 2, n plus 1, n and n minus 1. I hope you got the idea. N plus 2, n plus 1, then n minus 1. So now you compare it. N plus 2 is 21, n plus 1 is 20, n is 19, and n minus 1 is 18. So what do you get? N is equal to 19. This is the result. N is equal to 19. Same thing we are going to do here. We have 28C 2R colon 24C 2R minus 4 is equal to 225 by 11. It is going to be factorial 28. What is the question? Let me just write you the question. It is 28C2R colon 24 4C 2R minus 1. 2R minus 4 is going to be equal to 225 by 11. Now this can be written as factorial 28 by factorial 2R factorial 28 minus 2R, right? And now this you are going to write it as divided by factorial 24 by factorial 2R minus 4 and factorial 24 minus 2R minus 4, that is 24 minus 2R plus 4. 24 minus 2R plus 4 is 28 minus 2R. 28 minus 2R, you just take it above. 20 factorial 28 factorial 2R and factorial 28 minus 2R. Then you take this above. This one, factorial 2R minus 4 and factorial 28 minus 2R by factorial 24. This gets cancelled. 28 can be written as 28, 26, 27 into 25 and then factorial 24. And this 2R can be written as, you have 2R minus 4 in the numerator. You can write this factorial 2R as 2R, 2R minus 1, 2R minus 2, 2R minus 3. Then you come to 2R minus 4. This gets cancelled. 24 also gets cancelled. We had 24 factorial already in the denominator, right? So 24 in the denominator. Let me write 24. Now cancel it. So what do you get? 28, 27, 26, 25. Now 25 by 2R, 2R minus 1, 2R minus 2, 2R minus 3 will be equal to 225 by 11. So this all is going to be equal to 225 by 11. This is equal to 225 by 11. Now again same thing we have to compare. I need to be very careful about multiplying in such way so that you get the left side or the variation of left side or equality of left side. So what we are going to do? We are taking all the numbers on one side and variables on one side. So 28 into 27 into 26 into 25 into 11 by 15 into 15. I am writing 225 as 15 into 15. And now when you solve it, you try to solve it, say you can just cancel it by 27. 27 is 3 9 is a 27, right? Or you can say 3 into 3, 3 into 3, 9 and 3 into 3. So now 15 can be cancelled by 3. Whatever is possible, you can just cancel it and then now try to write it in the way so that it equates to the variable side. Okay, I'm just giving you an idea. So 3 is a 9 and this 5, this gets cancelled. Now 5 is cancels by 25. Now whatever is remaining, arrange in such a way so that you get 2R, 2R minus 1, 2R minus 2, 2R minus 3. So when you equate it, it will be 11 into 12 into 13 into 14, same multiplication will come. Result will be same. So when you equate, you see that the biggest one is what? 2R is the biggest one. And highest is 2R. And left hand side highest is 14. So you equate 2R with 14. The highest is 2R. Equate 2R with 14 and that is going to be 14. R will be equal to 14 by 2, that is 7. 7 will be the result. Now we have to prove that 4n C2n colon 22n Cn is equal to 1.3.5. It goes up to 4n minus 1 divided by 1.3.5 2n minus 1 whole square. Now see very carefully. This factorial 4n by 2n, let us write it first. It is 4n by 2n and this is 2n by n. Factorial, this is 2n Cn. So let us write 4n C2n first. So let us take the ratio first. See, this factorial 4n by factorial 2n, factorial 2n, factorial 4n by factorial 2n, factorial 4n minus 2n, that is, So now denominator is factorial 2n by factorial n factorial n. Now it goes up. So now this 4n, we'll just open it. 1, 2, 3, 4 till 4n. We know how to open the factorial. 1 from 1. Let it be factorial n square. Now we have taken, these are 3. These are factorial 2n, factorial 2n, factorial 2n. Okay, 3 are there. So one we have taken, factorial 2n, and second we have opened. Factorial 2n. Factorial 2n will be what? See, this is factorial 2n, and 1 also in the denominator. So it will be factorial 2n 3 times. Factorial 2n 3 times now in the denominator. Right? Well, you can see in the denominator there is 2n, 2n, 2n square. It is not that. It is only 3 times. 2n, 2n, 2n. One we have taken outside and 2 of them is here. 2 of them is here. Now, see. Let me tell you again. 2n, 2n, 2n. So it will be only 3 times. And 4n goes with n factorial n square. So it is not square. Only 3 are there. So we have taken 2 of them and we square it. Means it is square actually. And now 4n we have opened and let it be n factorial n square. Now what we have done here, even and odd we have taken separately. 1, 3 till 4n minus 1. It will be odd. It is odd. 1, 3, 5, 4n minus 1. What about even? You have 2, 4 till 4n. This is going to be even. And factorial n square remains there. Now here also we will take the even and odd. So 1, 3, 2n minus 1. This even odd we have taken. Now take the odd outside. 2, 2, 2, 4 and 2 minus 2n minus 2 and 2n. This odd even we have taken separately. Now here you see that in this 2, 4, 6, 4n, this one, factorial n square, let it be there. I am talking about 2, 4, 6 till 4n. This. I am going to change this one and I am going to change the below one also. Same thing. So 2 into 2 can be written as 2 into 1. 4 can be written as 2 into 2. 6 can be written as 2 into 3. And this goes up to 2 into 2n. Now this is 2n times. Every element has 2. So we are taking 2 outside, but it will be 2n times. And what is remaining? 1, 2, 3 till 2n. So you have, please understand, it is not 2 to the power n. It is 2 to the power 2n. It is going to be 2 to the power 2n. 2 to the power 2n it is. Okay. Now 2 to the power 2n it will be, and 1, 2, 3 like this. And what is this? This is factorial 2n. Now this is the first numerator change. Now I am going to the denominator now. Same thing I am going to do. 1, 3, 5, 4n minus 1. Let it be there. Okay. Now coming to the denominator, and we'll try to find some certain things which gets cancelled by numerator and denominator. Okay. So let me show you that how this denominator 2, 4, 6, 2n minus 2, 2n to be written. See. It will also give you, this will also give you 2 to the power 2n, and this will also give you factorial n also. And we are going to cancel it by numerator denominator. Now numerator we have done, just please watch me carefully the denominator I am taking. So 2, 4, 6, 2n minus 2 and now 2n. So I am writing 2 as, I am taking the denominator 2 into 1. 4 is 2 into 2. 6 is 2 into 3. It goes up to then 2n minus 1 we can write. This is 2 into n. Now take 2 outside and it is n times. So 2 to the power n you take, and then 1, 2, 3. This goes up to n. And what is this? Now this all is in square. If you see the denominator, it is in square. This is in square. So this means this is 2 to the power 2n. And what is this? 1 to n. This is factorial n. This is nothing but factorial n. 2 to the power 2n, 2 to the power cancel. And this is factorial n. And this is factorial n whole square. Now you cancel this. Factorial n square is already in the numerator. Now you cancel these two. Right? So what are you left with? You are left with 1, 2, 3, 2n. 1, 2, 3, 2n. 1, 2, 3, 2n. Right? So factorial 2n also gets cancelled. This is also factorial 2n. So this only remains, right? Now this is the next question, and we are going to take it in the next discussion.